Imagine this scenario. Your CTO walks into a high-stakes board meeting radiating excitement. He's been building prototypes with the latest industry favorites, e.g. LangGraph, Crew AI, AutoGen, or whatever the framework of the month happens to be. He presents a polished demo. The agents appear to work flawlessly, answering complex questions and processing internal data with ease. The board members are genuinely impressed for about 12 minutes. Then, the CFO asks the first real grounded question. What happens when an agent makes a critical mistake with customer financial data? Where exactly is the audit trail to trace that error back to its source? Sudden silence. The compliance officer follows up with a second question. How do we prove to regulators like FINMA that this autonomous system is operating strictly within defined regulatory boundaries at all times? An even longer, more uncomfortable silence follows. Finally, the board chair asks the third question. If this agent does something entirely unexpected at 2 a.m. on a Saturday, who is ultimately accountable? What failsafe stops it, and what system records exactly what happened? The CTO can only offer a weak response. Well, we are planning to build those features eventually. This illustrates what I call the orchestration gap. The vast space between what technical AI frameworks can do and what enterprise governance requires. This gap is the silent killer of AI initiatives. It isn't the technology that fails, it's the governance. Your AI framework might build impressive demos, but can it survive 15 minutes of rigorous board-level scrutiny from your CFO, legal counsel, and compliance officer? Currently, there are 354 companies in this space with $228 billion in funding, yet most of them cannot answer these three basic board questions. There are 5 fundamental questions that every board will eventually ask about any AI agent deployment. As of today, no major framework answers them natively. Not LangGraph, not Crew AI, not Google's ADK or Microsoft's agent framework. These frameworks are designed to execute tasks, not to handle the complex layers of governance, compliance, accountability, and self-healing. That is a completely different layer of architecture, one that most companies don't realize they need until they are sitting in that board meeting watching their CTO sweat under pressure. Layer 1 consists of foundation models like GPT, Claude, Gemini, and Llama. This is raw intelligence, and it is a commodity. Every company has access to it, so there is no competitive advantage here. Layer 2 consists of frameworks like LangGraph and Crew AI. These allow you to build agents that execute tasks. While important, these are also becoming commoditized. Everyone can use them, as evidenced by their tens of thousands of GitHub stars. Layer 3 is where the real value lies, orchestration and governance. This is the layer that most companies skip, yet it is the layer that determines everything. It answers whether you can trust the outputs, prove compliance, manage a fleet of 50 agents or more without descending into chaos, and survive a board audit. This layer does not exist in any open source framework. You cannot pip install governance or npm install compliance. It must be meticulously engineered, tested, and proven to work at a production scale with hundreds of agents operating 24/7 in regulated environments. While the AI agent orchestration market is projected to reach $8.5 billion by 2026, almost all of the investment is currently being poured into layers 1 and 2. Almost nobody but me is building layer 3. Which creates a massive blind spot for all the enterprises. For a CFO, this matters most. When Gartner predicts that 58% of business functions will use AI agents for at least one process daily by 2028, they aren't talking about simple chatbots. They are talking about agents managing financial data, supply chain logistics, and HR records. Companies deploying these agents without a robust governance layer will end up in the news. Not for their innovation, but for their incidents and fines. The companies that figure out layer 3 first will hold the most defensible competitive advantage because they will have the infrastructure that makes AI enterprise safe. An AI error without an audit trail is a financial reporting risk. An agent operating outside regulatory boundaries is a regulatory risk. Agents running across multiple clouds without unified governance is an operational risk. Most CTOs will claim the framework handles it because it handles technical execution, but governance, audit, and accountability are the parts they hope no one asks about until the meeting starts. CFOs who understand this will demand governance as a prerequisite, ensuring layer 3 exists before layer 2 ever goes into production. The best time to close the orchestration gap is before someone asks you why it exists. Most companies experimenting with AI agents today operate with 3 or 5. The particularly ambitious ones might reach 10. I am currently running 550 agents every single day in full production, operating simultaneously. I am going to reveal something the industry rarely discusses, something that fundamentally shifted my entire understanding of what AI agents are actually capable of. When you transition from 5 agents to 50, things inevitably get complicated. But when you move from 50 to 500, something completely different happens. Things get simple suddenly, but they get simple in a way that feels almost magical. In my book, Me and My Relationship with 1,000 Plus AI Agents, I describe this phenomenon as emergent reliability. It is the counterintuitive reality where a system comprised of hundreds of hyper-specialized agents becomes more reliable, more self-healing, and more trustworthy than a system with just a handful of generalist agents. Everyone assumes that more agents automatically mean more chaos. The reality is exactly the opposite. Every company with 5 AI agents thinks scaling to 50 will be 10 times harder. But what if I told you that scaling to 550 actually makes everything easier? To understand why, we must look at the 3 distinct phases of scaling AI. Phase 1 is the fragile phase, 1 to 10 agents. This is where every company starts. Each agent is a generalist trying to handle multiple complex tasks. If one agent fails, an entire business function goes dark. There is no backup, no specialization, and zero redundancy. It works in a controlled demo, but it consistently fails in a production environment. Phase 2 is the chaotic phase, 10 to 100 agents. I call this the valley of death. This is where agents start stepping on each other's toes. They compete for the same computing resources, produce conflicting outputs, and create a management nightmare. Without robust orchestration and layer 3 governance, this phase is unbearable. Most companies hit phase 2, experience the resulting chaos, and incorrectly conclude that AI agents don't work at scale. They are wrong. They simply lack the governance layer required to cross the valley. Phase 3 is the emergent phase, 100 agents and beyond. With a proper governance infrastructure, the system undergoes a qualitative transformation. Agents become hyper-specialized, doing one thing perfectly. If one agent fails, 3 others are already positioned to cover its function. Self-healing becomes an automatic background process. Audit trails are comprehensive because the agents are monitoring each other. In the production-grade AI ecosystem, 70% of the architecture is dedicated to governance, not execution. This often surprises people, but it shouldn't. Would you fly on an airplane where 70% of the systems were dedicated to the mechanics of flying and only 30% were dedicated to safety? Or would you want it the other way around? When you reach this massive scale with proper governance, 4 emergent properties appear that you simply cannot design into a small system. First is collective memory. The agents share a unified knowledge base of successes and failures. If one agent discovers a more efficient way to process a Swiss regulatory update, every other relevant agent in the 550 agent fleet knows it instantly. Second is anti-fragility. The system doesn't just resist shock, it gets better because of it. Every error is captured, analyzed, and used to strengthen the governance protocols automatically. Third is cross-domain insight. Because hundreds of agents are monitoring different data streams, finance, ESG, marketing, and legal, the system starts surfacing correlations that no human or individual agent was programmed to find. These properties are like biological systems. A single neuron is simple and limited. 1 billion of them create consciousness. Scale, combined with strict organization, creates something qualitatively different. What if the AI capabilities your company desperately needs don't exist in any individual agent but emerge naturally when you reach the right scale with the right governance? When you adopt a platform that already operates at this scale, you aren't starting from zero. You are plugging into an ecosystem that has already achieved phase 3. The emergent properties, the self-healing, and the proven governance already exist. You benefit from the institutional AI knowledge of 550 agents on day 1. Compare that to building your own 5-agent system from scratch. You would be stuck in phase 1. You would need years and millions of dollars to reach the reliability that an established ecosystem provides out of the box. Having agents that have been running, learning, and improving autonomously is a competitive advantage that cannot be replicated quickly, no matter how much you spend. Thinking small in AI isn't just a missed opportunity, it's a structural risk. Look at this landscape. Google's full-stack AI ecosystem is genuinely impressive, featuring Gemini 3 Flash, Gemini 3 Pro, and Gemma for lightweight models. They offer Veo 3.1 for video generation, Stitch for UI design, Whisk for image prompts, and Google Vids for video creation. Their developer tools include the Gemini CLI for coding, Jules for asynchronous coding assistance, and Anti-Gravity, an AI-powered IDE. They've also launched the Google ADK for building scalable agents, the A2A protocol for agent-to-agent communication, and Notebook LM for research. And that's not even a complete list. Microsoft has a comparable stack with Azure AI Foundry, Copilot Studio, and their new agent framework designed to replace AutoGen, all deeply integrated into Office 365, Teams, and Dynamics. Meanwhile, AWS offers Bedrock agents with enterprise-grade security, VPC isolation, and cloud formation automation. We have three tech giants, each spending tens of billions of dollars annually on AI, offering a full stack of tools from models to frameworks to deployment infrastructure. But here's the critical question that nobody in the industry seems to be asking. If Google, Microsoft, and AWS give you all the parts, who exactly assembles, tests, and certifies the aircraft? Google gives you over 20 AI tools. Microsoft gives you another 15. AWS offers a dozen more. But who turns those 50 individual parts into an aircraft that is safe to fly over your enterprise? The answer might surprise you. Nobody. Consider a parallel in aviation. Rolls-Royce makes world-class jet engines. Honeywell makes world-class avionics. Collins Aerospace produces flight control systems. And Safran builds landing gear. However, nobody flies on a Rolls-Royce engine. You fly on a Boeing or an Airbus. Why? Because someone must assemble those world-class parts into a certified aircraft. Someone has to integrate them, test them together, certify that the whole system is safe, monitor it in operation, and take responsibility if something goes wrong. That is the role of Airbus or Boeing. They don't necessarily make the best engines, they make the best aircraft. The difference is everything. Google, Microsoft, and AWS are the Rolls-Royces and Honeywells of the AI world. They make incredible world-class parts. But they are not assembling and certifying the aircraft. They sell you engines, avionics, and landing gear. Integration, certification, governance, and operational safety, that remains your problem. For a CFO, this analogy is perfect. In aviation, nobody questions why you need an Airbus. Nobody says, why don't we just buy a jet engine and build our own plane? That would be insane. The certification alone takes years. The integration expertise is decades in the making. The safety systems are the most complex part of the entire aircraft. Yet in AI, companies do exactly that. They buy Google's engine and Microsoft's avionics and attempt to build their own aircraft without certification, integration expertise, or safety systems. Then they are shocked when it fails to fly safely. Would you fly on a plane assembled by amateurs using Rolls-Royce parts? Then why would you trust your enterprise financial data to an AI system assembled by your IT team using Google parts? Big tech excels at core competencies. Google at models, Microsoft at enterprise integration, and AWS at infrastructure. But none of them provide the orchestration, governance, and compliance layer that turns those parts into a certified enterprise-safe system. Crucially, they don't want to provide that layer. It is not their business model. Google wants you to use Gemini tokens. Microsoft wants you deeper in Azure. AWS wants more compute hours. The governance layer that sits on top is a different business entirely. One that requires being vendor neutral. Something important is happening that most leaders don't understand yet. Google just released their A2A protocol for agent-to-agent communication, and Anthropic has launched MCP, the Model Context Protocol. These are attempts to standardize how agents talk to each other and connect to tools. They are essential infrastructure. A2A lets agents built with different frameworks discover and communicate. MCP standardizes connections to data sources. Together, they create a universal language for AI. But here's the truth. Protocols define how agents communicate, but they do not define what agents are allowed to communicate. They don't enforce rules for when agents disagree. They don't create accountability for decisions, and they don't generate compliance documentation. If you are evaluating AI platforms right now, don't just ask which vendor has the best LLM engine. Ask, who is going to certify my aircraft? Who integrates, governs, and takes responsibility for the whole system operating safely with your enterprise data? That is the only question that truly matters for the future of your organization. I want to discuss a critical topic that is almost entirely ignored in AI marketing, yet it is the single factor that determines whether your AI investment succeeds or fails. The science underneath the system. Currently, hundreds of companies are selling AI agent solutions. They all offer impressive demos, slick marketing, and promises of transformational outcomes. But here is the uncomfortable truth. Many of them are nothing more than thin wrappers around a large language model, LLM, with a fancy interface. How many of these platforms are grounded in decades of academic research on multi-agent systems, reinforcement learning, and decision theory? The difference is far from academic. When your AI system is handling sensitive financial data, making autonomous compliance decisions, or generating reports destined for government regulators, it seems to work as a dangerous standard. In an enterprise environment, you require provable reliability. Provable reliability is born from mathematical foundations, not marketing claims. If you are evaluating a vendor, ask them to explain the mathematical foundations of their reliability claims. Are they building on hard science, or are they simply hoping the underlying LLM gets it right this time? There are 4 specific fields of computer science that should form the foundation of any enterprise-grade AI agent system. Understanding these pillars in plain language will help you see why they are essential for your business survival. Pillar 1, multi-agent systems, MAS theory. This is the science of how multiple autonomous entities interact to solve problems that are too large for a single agent. It isn't just about having many agents, it's about the mathematical coordination between them. In an enterprise, MAS ensures that your finance agent, your legal agent, and your operations agent don't work at cross purposes, but instead function as a cohesive, optimized unit. Pillar 2, reinforcement learning with human feedback, RLHF. This is how agents learn from your best people. It isn't about simple programming, it's about creating a feedback loop where the AI observes human experts and refines its decision-making based on their high-level judgment. This ensures that the agent doesn't just act smart, but acts in alignment with your company's specific professional standards. Pillar 3, constitutional AI and value alignment. This field focuses on embedding a set of non-negotiable laws or a constitution within the AI's core logic. Unlike simple prompts that an LLM can ignore through jailbreaking or hallucinations, constitutional AI provides hard mathematical boundaries that the agent cannot cross. It is the definitive answer to the question of how to keep autonomous systems safe and ethical. Pillar 4, decision theory under uncertainty. This is perhaps the most important for a CFO. Traditional software provides binary outputs. Decision theory allows an AI to quantify its own uncertainty. For a CFO, this is the difference between an AI that blindly says revenue will be CHF 12.3M and one that provides a sophisticated analysis. Revenue will be CHF 12.3M with a 95% confidence interval based on current data, though this projection is sensitive to 3 specific assumptions I have flagged for your strategic review. Which of those 2 would you trust with your quarterly forecast? The signals of a foundation-based platform are clear. They provide mathematical guarantees rather than vague explanations. They offer defined boundaries instead of unlimited potential. They provide measurable reliability metrics rather than just impressive demos. When evaluating any vendor, ask this one question: what happens when the AI is wrong? If they cannot provide a detailed answer regarding failure detection, error containment, and automated recovery procedures, they haven't done the science. They are simply hoping the LLM doesn't hallucinate, and hope is not a professional strategy. Finally, consider the role of intellectual property. While the academic foundations of MAS or decision theory are public knowledge, the specific application of these sciences to enterprise governance is novel and often patentable. How you combine these theories into a production-ready system with 550-plus agents, self-healing protocols, and IBCS-compliant reporting is where true innovation lives. Our patent portfolio covers these novel applications because they are the secret sauce of a production-grade platform. This matters to your evaluation because a platform with patent-protected innovations cannot be easily replicated by a competitor who simply reads the same research papers. It creates a defensible moat for your organization. If you could choose between 2 AI platforms, one with patent-protected innovations and another one using open source frameworks that anyone can copy, which one would you choose? The answer should be always the same. In the world of business strategy, there is a fundamental concept known as a MOAT. Popularized by Warren Buffett, it describes the structural barrier that protects a company's competitive advantage from being eroded by competitors. In the modern era, a great product can be cloned. A strong brand can be challenged by a disruptive newcomer. Even proprietary technology can be replicated given enough time, capital, and engineering talent. However, a compliance moat is fundamentally different. It is not just a piece of software, It is the unique synthesis of technology, rigorous process, institutional governance, immutable audit trails, established regulatory relationships, and specialized knowledge built over years of production-grade operation. It is a compounding asset that is almost impossible for a competitor to replicate quickly. The defining truth of the AI era is this: the company with the deepest compliance moat wins. It is not necessarily the fastest company or the one with the cheapest solution that survives the next decade. It is the most trusted. Over the course of this series, we have explored the entire AI agent landscape, from catastrophic security failures and hidden operational costs to the orchestration gap, the advantage of scale, the academic foundations of the technology, and the complexities of the vendor ecosystem. Today, we tie all of those threads together to define what a true compliance moat looks like. This is the competitive edge that will separate the leaders from the laggards in the enterprise AI space. While Google has a technology moat, Microsoft has a distribution moat, and Apple has a brand moat, you must ask yourself, what is your moat? If you do not possess a compliance and governance moat, in the eyes of a regulator or a cautious board, you don't have a moat at all. A robust, enterprise-grade compliance moat consists of 7 distinct layers. Each layer builds upon the one beneath it, making the total structure exponentially harder to copy. Layer 1, IBCS-compliant output standards. Communication is the lifeblood of finance. By enforcing international business communication standards, you ensure that AI-generated reports are instantly understood and free from the ambiguity that plagues standard LLM outputs. Layer 2, constitutional governance guardrails. These are the hard-coded laws of your system that prevent agents from acting outside their authority, regardless of the prompts they receive. Layer 3, comprehensive audit trails. In a regulated environment, "it worked" is not an answer. You must be able to prove exactly how every decision was made, what data was used, and which agent was responsible. Layer 4, multi-model routing with cost governance. This ensures that your agents are not only effective but efficient, automatically selecting the most cost-effective model for the task while maintaining strict data residency and security protocols. Layer 5, self-healing with institutional memory. As your fleet of agents grows, the system learns from its own errors, creating a self-correcting loop that hardens your operations against future failure. Layer 6, cross-domain intelligence. This is the ability of your AI ecosystem to find correlations between finance, legal, ESG, and marketing data, insights that no human or isolated agent could ever surface. Layer 7, patent-protected innovations. This is the final seal on your moat, ensuring that your unique applications of AI science to enterprise governance are legally protected from replication. Layer 1 alone provides value, and layers 1 through 3 are compelling for any compliance officer. But all 7 layers together create a structural barrier that would take a competitor years and tens of millions of dollars to duplicate. Most companies currently treat compliance as a defensive necessity, a cost center required to satisfy regulators. That narrow perspective is leaving billions of dollars in value on the table. The smartest companies, particularly in the DACH region, are beginning to view compliance not as a burden but as a weapon. A deep compliance moat allows you to win high-stakes tenders where security is the primary concern. It attracts top-tier investment from funds that require rigorous ESG and governance standards. It reduces your corporate insurance premiums because your operational risk is demonstrably lower. It grants you unprecedented speed to market because your systems are compliant by design, allowing you to bypass the months of manual review that paralyze your competitors. Finally, it serves as a magnet for talent because the best engineers and managers want to work on systems that are built to last, not systems that move fast and suddenly break. This is the fundamental mindset shift required for leadership in 2026 and beyond. Thank you for your time and for engaging so seriously with us. We are currently at a unique moment in history where the rules of the future are being rewritten.